Hello, grade 12. Welcome to the grade 12 mathematics summer lessons, and this is our session 5 where we'll be focusing on sigma notation. Okay, if you could take a look at the content outline, sigma notation is unit 5, hence this is session 5, right? So if you check unit 5 on your textbook, Platinum Mathematics grade 12 learners book, in unit 5 is sigma notation, and this is session 5 and we'll be mainly focused on this. Okay, unit 5, sigma notation. What is sigma notation, right? So sigma notation is a very useful and compact notation. Keyword there, compact notation. In other words, it's like a notation that summarizes something, that puts something that is long in a compact or summarized way for writing, and this is a notation for writing the sum of a given number of terms of a sequence. So the sum may be written out using the summation symbol. That is the symbol that we use, and it's called sigma, right? So here in this case, because we have been dealing with geometric series and arithmetic series, and their sum of geometric series, sum of arithmetic series, you might find out that you want to write those sums in a compact or summarized or a short way, right? So that's where you start to use this notation called sigma notation, and that's the symbol there. It's a Greek letter S in the alphabet. Some people can call it E, and it's called sigma, or which also stands for sum. Sum. It represents sum. Okay, for example, we might want to write the sum from 1 plus 2 plus 3. Let me just use an arithmetic series. 1 plus 2 plus 3 plus 4 plus up until we reach 1000, right? If you are writing all these sums, you're gonna take a lot of space. If you are adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 up until you are adding up until 1000, it's gonna take a lot of space, right? So in order to represent that sum, right, that sum, we can ultimately use what? Sigma notation. So sigma notation is that notation that will just write out this sum in a compact or summarized way, right? How do we do so? So we said we use the symbol E there, right? So just take a look at this box here, and we just represented how you can do this. So in your sigma notation, obviously it's gonna have that symbol E representing the sigma or the sum, right? So it's representing the summation, right? So here in the middle, right, you put the formula for the nth term, or the general term, right? Or what is known as the nth term, where there is this xi. So you put the nth term, right, in the middle of that sequence. So in this case, we are gonna get the tn for what? For arithmetic, because we have a common difference of 1. So we're just simply gonna get a common difference for arithmetic, I mean the general formula for arithmetic, and we're gonna substitute it there in the middle, right? So I equals to 1. This is our starting point. I like to call it our starting point, right? So although they told you this is the lower limit, that is the first value of I, or sometimes they can use K, they can just use any letter, right? So long as the letter used there, it's also found in the general formula. If they use I, you have to get what? Ti, right? Which is sort of like Tn, the nth term, but it's just that they are using I, right? So it's our starting point. If it starts from 1, that's it. And on top here, you get our upper limit, or the last value of r. So I like to call it an ending point, our ending point, right? So where we're gonna end. For example, I can say I equals to 1, so it means that I'm gonna start adding them from t equals to 1, right, up until I end. Maybe if here on top I have 50, it means I'm gonna end on t equals to 50. So that's basically what we are saying, and this notation is called what? Sigma notation. Okay, let me just explain further in the next slide. Okay, so in this notation, if you can check, I already explained that this is called sigma, right? That symbol, it's called sigma, which also stands for what? For summation. So as I said, it's a Greek letter E S yeah, and it's called sigma, and it indicates that we want to sum of we want the sum of all terms, right? Let's take for example, you are given a geometric series. Okay, sorry about that. Let's say for instance you are given, here is our geometry, this series, right? It's our series. They didn't tell us which series is this, but we can see 1 2 3 4, there's just a common difference of 1, so it's an arithmetic series. Then we can represent that sum in a summarized or compact way, and we say we use the notation called what? Sigma notation. And I already explained that here in the middle you're gonna put the formula for the nth term, right? So always just use n equals to 1, right? So some people may choose k equals to 1, okay, something like that. So just start from 1 always, right? So here on top you'll put like how many terms are we adding, right? So if I'm adding from term number 1, I'm going to end up on term number 20, like that, right? So that is the last value of n, right? But this really doesn't mean that always you have to put this value here. So here we are just putting 20. This 20 does not, it's not the same as that one, right? So this 20 here, it's like indicating how many terms are being added, right? For example, in a geometric series, if I had 2 4 8 then maybe 32. So this would represent, I don't know how many terms are being added. So on top I was not gonna put 32, but I was gonna calculate n to say how many number of terms are being added in this series, obviously by letting our last term 32 to be equals to tn, and so for n. So after getting n, let's say for instance I get my n as equals to maybe 6, right? So it means on top I was gonna put what? 6, because we have 6 terms being added together. So here n is the general formula, as you can see that if you go and calculate the general formula there for this series, arithmetic series, you'll find that it's n, right? Because it's like tn equals to a plus n minus 1 d. Our a is 1, n minus 1, our common difference is 1. So when you multiply those things, n minus 1 plus 1, 1 cancel 1, so you get your tn is equals to what? N. That's why they put n there in the center. So there you put your tn. Here you just always just use n equals to 1, and on top you just put the value for what? The last value of n, to show how many terms are being added, right? So that's basically what you do. Okay, another important information, in sigma notation, if we are given a sigma notation like this, right, we might want to learn, let me just use a different color, how to calculate the number of terms, right? Number of terms. So there's a formula for calculating the number of terms on sigma notation, right? If you have your sigma notation and they say determine how many terms were added in this sum. Let's say for instance we are using this one as an example, right? So it's in sigma notation. So to get the number of terms, what we do is to say n equals to top minus bottom plus 1. So this is the formula. So top, I mean the value on top, right? So it's what? It's 20 minus bottom. The value at the bottom is 1 plus 1. So it's 20 minus 1 plus 1. This will give me 19 plus 1. My number of terms that are being added will be 20. So most of the time, if n equals to 1, you'll find that the number of terms that are being added will be the value on top there. It's just equal to that value. But sometimes they might give you a sigma notation. Let me just use a different color in this way. They say n equals to 3, then they give you 51, and they say 2n plus 1. So this is a sigma notation, and they might ask you to calculate the number of terms that are being added in this series, right? So although n starts from 3 up until 51, to get our number of terms, we are going to say top minus bottom plus 1, right? So that's what you do. Your top is what? Is 51. That's the value on top there, minus the bottom. The value at the bottom is 3 plus what? Plus 1. So 51 minus 3, it's gonna give us, I think, 48 plus 1. This is gonna give us what? 49. So it means that the number of terms that are being added in that series is 49 terms. So our n starts from 3 like that. Okay, let's just take a look at an example, then you'll really understand this concept. Okay, let's look at worked example 1, and it says evaluate, and you're given the sigma notation. What does this mean? Okay, this means that they need the sum, the answer for the sum of this series. So we need to check which series is this. Is this geometric, or is this arithmetic, or it's something else? So how do we know which series or which sum of this series is? We look at the general formula. Don't forget I told you the general formula is found in the middle there, right? And if you take a look at the general formula there in the middle, you'll notice that this is for arithmetic series. So they are summing up the terms of arithmetic series, right? So what's their starting point? Their starting point is from when n equals to minus 4. They are summing them up from n equals to minus 4 up until what? Ending point is at 20, up until they reach 20. Okay, so in order to calculate this sum, what I would advise you to do always, just first write the first three terms of this sum, right? So how do we do so? Don't forget we have the nth formula there. We have our Tn, it's 5n minus 2, right? So if we have our Tn, which is equals to 5n minus 2, then we can get the first three terms of this series, right? But don't forget, very important, and that's where most learners make mistake, because they would want to to get the first three terms of this series. You might find a learner is going to find T1, T2, T3, and they say, I got my first three terms of the series. No. This is not the case in sigma notation. So in sigma notation, we have to be very careful. We work with our starting point, our starting index, right? So our starting point is when n is equals to minus 4. Then we increase thereafter, going towards our ending point. So it's starting when n equals to minus 4. That's our starting point. It means that if we want to get the first term, we're going to substitute n equals to minus 4. Then that's our first term that's being added there. So this will be minus 20 minus 2 minus 22. So this is the first term that is being added. So from minus 4 we are approaching 20. So as we move up there, it's gonna be what? N equals to minus 3. So this is our second term. that is being added. So minus 3 minus 2 minus 15 minus 2 minus 17 as our second term that is being added. As we are moving up another term, so it will be n equals to minus 2. So you see, so this starting point is very important, right? You don't just do as you have learned in the previous session. Here, when we are dealing with sigma notation, we have to see when are they starting to add this term, and our starting point is at minus 4, and we increase thereafter towards that positive 20 like that. So as we move from minus 3 is minus 2, then when there is n, I'm just gonna substitute minus 2 and get the answer minus 10 minus 2 minus 12. So the first three terms that are being added is minus 22 plus minus 17. Okay, plus and minus is just gonna be minus 17 minus 12 like that, plus up to so forth, right? Okay, after writing the first three terms, so in the just previously, I've just been showing you how to get those first three terms of that series, right? So very important, as I've said, you check your starting point and you substitute n equals to minus 4, and you move going up n equals to minus 3, n equals to minus 2. Then you substitute where there is n and you get the first three terms like that, right? Okay, after getting those three terms, now you can see that our ending point is at 20, right? When n equals to 20. So if you substitute n equals to 20 there, you'd have gotten your last term, right? So because that's the ending point on top. So if I go and substitute 5 into 20 minus 2, I can determine my last term. So 5 times 20 is gonna give me 100, minus 2 is gonna give us 98. So our last term there, it's 98. And how did we get it? We substituted the ending point on our general formula to get the last term. Okay, so after doing this, now we have our last term, right? And we have this first three terms, minus 22, minus 17, minus 12, right? So don't forget, according to the general formula of this series, this is a sum of an arithmetic series, right? And we know that to get the sum of an arithmetic series, there are two formulas that we can use, right? The first formula is Sn equals to n over 2a plus last term, and the other formula is Sn equals to n over 2a plus n minus 1d, right? Okay, so the first formula, we use it when we have the last term, and we just calculated the last term is 98, and we also have the first term is minus 22. So it's gonna be easy to use the first formula. Okay, so to get the sum, remember when they say evaluate and they write sigma notation, they are actually saying get the sum of this series. So it's just that they are representing it using sigma notation, using this compact or summarized notation. Okay, so now our a is what is minus 22, our last term, which is the last term which we just got by substituting 20 there as our endpoint, and we got what, 98, our n. Don't forget, in the previous slide, just show you how to calculate n in sigma notation. You say top minus bottom plus what, plus 1. What is your top value? On the top is 20 minus, be very careful here because your bottom is negative, so I just put it in brackets, don't forget, then plus 1, then negative and negative, they're gonna give me positive, then it's 20 plus 4 plus 1, then it's gonna give us 25. So there are 25 terms that are being added. Now I can go and quickly calculate the sum or evaluate this sigma, right? So in evaluating it, it's sum of 25 terms. So where there is n is 25 over 2. What is our a? Our a is our first term minus 22 plus our last term is 98. Then we can get the answer for the sigma notation or for the sum. Okay, the final answer, it's gonna be 950. So when they say evaluate, they need the answer for this sigma. So it's what? It's 950 because it's sum of an arithmetic series where n start from -4 up until 20. So its value, it's 950. Okay, let's just explore a different example and let's see how it goes. Okay, let's explore example 2 now and see how it goes. It says evaluate sum of when n start from 1 and on top they put that symbol. Don't forget what that symbol represent. That it's like an 8 that is sleeping, and we know that that is called infinity, right? So they are adding terms from 1 up until to infinity. So the ending point is to infinity, right? It means what do they need? They need the sum of infinity. Sum of infinity. And we know the formula for sum of infinity is a over 1 minus r. Very simple. You must get your a and you must get your what? Your r, right? So take a look at the general formula here in the middle. It says our Tn is 3 into 1 over 2 n minus 1. So most of the time they might like to play with your mind, right? So if you check this general formula, it's in the standard formula way of saying a into r exponent n minus 1. So it's perfect, right? So we can identify our a is 3, we can identify our r is 1 over 2. But be very careful, right? Because sometimes they might give you this general formula as maybe Tn equals to 3 into 1 over 2. They just put n, or they put something else which is not n minus 1 at the exponent. So how do we get a and r in that case? What you do, you go and just substitute the value of the starting point where there is n. That will be your first term. You substitute the following value, n equals to 2, then that is your second term. To get your ratio r, you divide the second term by the previous term. So be very careful and check whether they gave you that general formula in the standard formula way, right? So that you may not make mistakes. So fortunately in this example they give us in the standard formula way, so we can just quickly identify it. A equals to 3, r equals to 1 over 2. Then we can get the answer of that sigma notation. So if we are evaluating it, I'm just gonna write equal sign in front of it and write those things, and then it's gonna be our a, which is 3 over 1 minus, don't forget after negative just put whatever falls in brackets so that you may not make mistake. So it's 3 over 1 minus 1 over 2, then the answer will give us 6. So the answer of that sigma is what? Is 6. Okay, so let's explore this different example using sigma notation where we have to determine the value of n, right? So if you can check, the value of n is on top, it's our ending point, and our r start from 1 up until n. So what do they need? They need the number of term, right? Because every time I told you, if it's starting from 1, the number on top will represent what? The number of terms. So in this case, this represents the number of terms that are being added together in order to get the sum of what? 1640. Okay, so before solving this, we must identify which series is this. Is this geometric or arithmetic or something else? Okay, and I told you that we look at the general formula in the middle, at the center there. Our Tn is 1 over 2 into 3 exponent r minus 1. So we can see this is a general formula for what? For geometric, right? So this is a sum of a geometric. After identifying that, we are going to use the formula for sum of geometric in order to solve this problem. So sum of geometric, it says a into r exponent n minus 1 over r minus 1. Or you can use the other formula that says a into 1 minus r exponent n over 1 minus r. So what is our sum? We already given the answer for the sum. It's 1640, right? So where there is Sn, we are going to put 1640 as that is our sum. What is our value of A? So if you check this Tn that we are given, it's in the standard general formula way of a geometric sequence, right? So it's easier to identify A, but sometimes they might give you a general formula like this. Let's say they've given us 1 over 2 3 exponent r. So our A wouldn't be 1 over 2, right? Because this is not the general standard formula that we know for what? For geometric sequence. So what you do in this case, you check the starting point, r equals to 1, you substitute that value there, then you'll get your value of your first term. So in most cases, they like to do this. They'll just give you the Tn that is sort of like look like a geometric one, but not entirely like in this standard formula for geometric. So what you have to do, you take your value for the starting point, you substitute it, then you will get the value of the first term like that. Okay, so in this case, this one is sorted. It's in the general standard formula way. So our A is 1 over 2, as we can see, and our R is 3, because that one is in that standard formula. So our A, where there is A, I'm gonna replace by 1 over 2, R I'm gonna replace by 3 minus 1 over 3 minus 1. So 3 minus 1 is gonna give me 2. When I cross multiply, 2 will multiply with 1640, then it will give us so it will give us 3280, right? So we'll have 3280 is equals to 1 over 2 into 3 exponent n minus 1. So I can divide both sides by 1 over 2, or I can multiply by 2, so that 2 and 2 can cancel. Then after cancelling, I'm left with 3 exponent n minus 1. 2 times 3280, it's gonna give me 6560, right? So I can take 1 to the other side, it will be 6561 is equals to 3 exponent n. Now I need to raise this number to the base of 3. How do we do that, right? So you use your calculator. If you're using a Casio calculator, you press it 6561, then you press equal sign, then you press shift, and you press a button where on top there is capital letter B, or what is written fact, the button under there. Then it will show you 3 exponent 8. So it's a very simple method. So then now the base are the same, we can equate what? The exponents. So our n is 8. Determine the value of n equals to 8. What does it mean? It means that in this geometric series, for them to get 1640, they had to add up 8 terms together. Okay, worked example number 4, expressing sigma notation. Expressing series in terms of sigma notation. So all along we have been just evaluating or determining the values of sigma notation, and in our last example just now, we just calculated or show you how to calculate the value of n using sigma notation. Now they might give you a question and say like give you a series, and they tell you that express the following series in sigma notation, right? It's a question that there's absolutely 95% chances of you getting it in any past paper. They just give you a a series, and they say express this series in terms of sigma notation. Don't forget, sigma notation is a compact notation, and this notation is really used to represent the sum of a series in a short or summarized way, rather than us going and write that sum, showing adding all those terms, and it can take a lot of space and time. So we can simply represent that sum using that small sigma notation, and it will just be covering everything. Okay, so let's take a look at number one. Okay, let's take a look at number one. We are given, they say express the series below in sigma notation. They give you 12 plus 4 minus 4, then they are showing you it's going up until minus 276. So before expressing a series, you must first determine whether this series is geometric or arithmetic, right? Obviously this is for you to for your Tn, right? For your Tn there, the center of the sigma. So let's go and determine. I think this will be an arithmetic series. So how do I know? Let me calculate the common difference. If there's no common difference, then it's not arithmetic. It might be geometric. So my term number 2 is 4 minus term number 1 is 12. This must be the same as term number 3, which is minus 4 minus into 4. 4 minus 12, it's minus 8. Minus 4 minus into 4, it's gonna give me minus 8. So we have a common difference. Then this is an arithmetic series, right? So the Tn is for arithmetic, we know. So we can go and calculate our Tn. It says a plus n minus 1d. Our a is our first term, which is 12 plus n minus 1. Our d is our common difference, which is minus 8. So this is 12 plus minus 8 times n. It's going to give me minus 8n. Minus 8 times 1 is going to give me, minus 8 times minus 1 is positive 8. So I have minus 8n. 12 plus 8, it's 20. So our Tn, it's minus 8n plus 20. So in our sigma notation, if I had to represent that series in sigma notation, I can actually say this can be represented as, or is equals to, the sum of, so it's sigma notation. Always choose n equals to 1, or let me just use a different color. I don't know if I choose, let me see this, whether it will be visible or not really. Yeah, this one. So in representing my sigma notation, n equals to 1. Don't be too fancy, or you want to say n equals to 3, what. No, just use the standard one, n equals to 1, right? So in the middle here, or in the center, we put the nth term, which is minus 8n plus 20. So when you put n equals to 1, on top here, you're just gonna put the number of terms, right? Because that's how it is. And if n equals to 1, we know that on top, when we calculate number of term, and top minus bottom plus 1, it will still remain that one on top. So you're just gonna get how many terms are being added, then you put it there on top, right? So to calculate how many terms they were being added in this series, so we know that we have our last term, and if we have our last term is the same as what? As Tn. So where there is Tn, I'm gonna put minus 276 and calculate the number of terms, right? So minus 276, let me use black. So minus 276 minus 20 is equals to minus 8n. So it's minus 276 minus 20, which is minus 296. Minus 296 is equals to minus 8n divided by minus 8 divided by minus 8. Then our n, it's gonna be divided by minus 8, it's gonna be 37. So we can see that they were adding 37 terms. So on top there, I'm gonna put what? we're gonna put 37 as our ending point. So this is how we can express this series in sigma notation. Very simple. Just say n equals to 1. At the center you put the general formula. On top you calculate number of terms, and you express it in that way. Okay, let's take a look at example number 2. We are given the series 100 plus 40 plus 16 plus, it's going like that. Okay, so firstly we must determine which series is this. If you can calculate the common difference, I doubt there can be common difference. 100 to 40, the difference is big. 40 to 16, it's like a small a bit. So obviously this is geometric, right? This can be geometric. Let's calculate R and let's prove if really it's geometric. Term 2 divided by term 1, term 3 divided by term 2. If these two are not equal, then it's not geometric. So 16 divided by 40, 40 divided by 100, 40 divided by 100, it's 2 over 5, 2 over 5, and 16 divided by 40, also 2 over 5. So this is a geometric series, right? But if you can check this geometric series, it's just being added and they put those 3 dots. We don't have the last term. No last term. No last term. So it's being added to infinity. If you check, it's being added to infinity. So it means that we can't determine the number of terms here because they are just adding and there's no last term. So this will be sum to infinity. Don't forget, sum to infinity. It's also for a geometric series where there's no last term, right? So we can calculate Tn a into r exponent n minus 1. What is our a? Our a is our first term, which is 100. Our r is 2 over 5 exponent n minus 1. Then we can represent it in sigma notation. I'll just put it down here. This is the sigma standing for summation n equals to 1. Just say n equals to 1. So there is no last term. It's going to infinity. So we just put that symbol of infinity on top, and in the middle we just put what? We just put the general formula, which is 100 into 2 over 5 exponent n minus 1. So this is how you can express this series in sigma notation. So be very careful when you are doing this. Just do it slowly and carefully, so that you can get full marks. Okay, let's look at example number 3. Question 3. We are expressing this series in sigma notation. So we must identify if this is geometric or arithmetic, right? So let's see. Let's calculate the common ratio and see if we can't get a common ratio. So if we can't get a common ratio, we'll just calculate the common difference and see from there. So term number 2 is minus 10 divided by term number 1 is 5. Term number 3 is 20. Term number 2 is minus 10. This will give me minus 2. And also this side, 10 divided by minus 10, it will give me minus 2. Great. So we have a common ratio. So this is a sum of a geometric series. So if I can calculate Tn is a into r exponent n minus 1. What is my a? Is our first term, which is 5. Our r is minus 2 exponent n minus 1. Okay. So if I want to represent this in sigma notation, let me just use this color there and put it on top. N equals to 1, and here we're gonna put 5 into minus 2 exponent n minus 1. So if I put n equals to 1, we know that the number that is coming on top represents the number of terms that are being added, right? But you don't know the number of terms that are being added in this series. What can we do? We are going to calculate the number of terms because we have the last term, right? Our last term is 5120. So where there is Tn, I'm gonna put 5120 and calculate the last term. So it's gonna be 5120 divided by 5. If I divide by 5 both sides, then it will give me if I divide by 5, this 5 cancel this one, then here I will get 1024 is equals to minus 2 into exponent n minus 1, right? So to calculate n here, I have to I can first break this to be like minus 2 exponent n multiplied by minus 2 exponent minus 1. Yeah, I can do that. Minus 2 exponent. So you know that if we're multiplying powers of the same base, we add the exponent, it will still remain minus 2 and minus 1. Why am I doing this? This is negative 2. And if I try to express this in the power of 2, you'll find that I'm getting a positive, and it will be really difficult to solve for n. So I'm just trying by all means so that I can divide by negative, so both sides can be negative and just express like that, right? So here we have 10 2 4. So this was a bit tricky, so we divide both sides by minus 2 exponent minus 1 divided by minus 2 exponent minus 1. This cancel out this, right? Let me write here. Okay, so that cancel out that. So I'm going to have if I take this side, so I'm saying 1024 divided by minus 2 exponent minus 1 is gonna give me minus 2048. Minus 2048 is equals to minus 2 exponent n. So I can raise them to the same powers, to the same base, by saying minus 2048 is equals to shift, then you press fact, right? It will give us what? 2 exponent 12, so it will be minus 2 exponent 12 is equals to minus 2 exponent n. So now the base are the same, both minus 2, then we just equate the exponents. Our n is what? Is 12. So we can see in this series they were adding how many terms? 12 terms, right? Okay, they were adding 12 terms. So I can go now in my sigma notation. Don't forget n equals to 1. If I put n equals to 1, whatever goes here on top as our ending point will represent the number of terms that are being added. So it's 12 there. So that is how you're gonna express this series in sigma notation. You can see sigma notation is very summarized, very compact, and it's this way that they use in order to represent those big series in a short or summarized way. Okay, so here's your fun activity, and let's see who can solve this. So they say express the following series in sigma notation. You are given 1 plus 4 plus 16 plus 25 plus 36 plus 49, right? So in this one you must be very careful. Just look at the series. If I can give you a hint, this is not a geometric series and it's not an arithmetic series. You have to just determine by yourself what series is this, what sequence is it forming. By looking at the numbers, you'll see that there's a certain sequence it's forming. Then you just need to be creative like that. And let's see who can solve this, and just drop your answers on the comment. Then I'll on the comment section. Then I'll respond from there. Okay, great stuff. This marks the end of our session. This was session 5, where we were focusing on sigma notation. Thank you very much for joining. Thank you for watching. And we'll meet next time. Enjoy the rest of your day. That's all for me. Goodbye.